Welcome to another lesson with Mrs. Abdu. Today we're talking about maps and scale drawings. Our question, how can you use proportional relationships to solve problems that involve maps and scale drawings? A scale drawing is an enlarged or reduced drawing of an object that is proportional to the actual object. Think of blueprints for the school, or blueprints for a house, or a scale model, okay? A scale is the ratio that compares the length in a scale drawing to the corresponding length in the actual object. A 1-inch long scale drawing is made of a 15-foot boat. So the scale can be written as this, 1 inch to 15 feet, or 1 inch to 1 inch equals 15 feet. Okay, so here's the drawing on the left and the actual on the right. So we can use this scale to find an actual distance given a scale drawing. You can also use a scale to make a scale drawing given an actual distance. You can go either way. So we're going to consider the scale. 1 inch equals 15 feet. We can write two different ratios. 1 inch over 15 feet, or 15 feet to 1 inch. Okay? Now, it says use one when you know the actual here, and use one when you want the actual distance. As long as you're consistent when you set up your proportion, you shouldn't have any issues. So the American golden plovers migrate from Nova Scotia to South America every fall. The map shows the route that birds fly. About how long is the migration? So let's set up a proportion. We have 1 inch to 400 miles. So when I look on my ruler over here, we have, starting here, 0, 1, 2, 3, 4, 5, we have 6 inches. We want to know how many miles. Now notice, my inches are in the numerators of both. My miles will be in the denominator. So when I cross multiply, we get x equals 2,400 miles. Let's try another one. What is the actual distance between Jacksonville and Orlando? I look at my scale, 1 inch to 110 miles. On my ruler here, I have 1 1/2 inches, 1.5 inches over x miles. When I cross multiply, I get x to be 165 miles. What I would like you to do is I want you to do this question here, where we're looking at the aquarium and we're looking at the billboard for the aquarium. They give me the scale. We want the dimensions of the billboard, and we want the area of the actual billboard. So work on that, and we'll come back. So when I came back to this, and I set up my proportion, I got this side here to measure 12 feet. And since this was doubled, 16 inches is double 8 inches, I can just double 12 feet here and make it 24 feet. Okay, now they're asking, so the dimensions are 12 feet by 24 feet, and my area will be 12 feet times 24 feet, which will give me 288 feet squared. Please make sure you have your units. We need those units. Okay, try the next one for me and see how you do. I'm hoping that when you did that, you found the first side here to be 1 foot. And because 1 inch represented half a foot, 3 inches would represent 1.5 feet. In the area, length times width, 1 times 1.5 gives me 1.5 feet squared. Our next one is a little more difficult. A tennis court is 36 feet wide. So I drew myself a tennis court. It's 36 feet wide. A scale drawing of the court is 2¼ inches wide. 2¼ inches. Okay. And the length is 5 1/16 inch. Okay. So what we need to do is we need to find the scale that was used to make the scale drawing. Okay. So this right here is irrelevant to us right now. We need to convert this here. We've typically been going inches to feet for all of these, so let's do that. Let's do 2 1/4 inches represents 36 feet. And we want to simplify this fraction. They're asking for us to find the scale. Scale is going to be inches to feet, so I convert. This becomes 9/4, and this is 36. Multiply by my glue wasn't working. Multiply by my common denominator of 4, and I end up getting 9/144. I'd like to simplify that, and I get 1/16. So my scale, 1 inch equals 16 feet. For the next one, we're making a map of the United States. The map below uses a scale of about 1 centimeter equals 100 miles. Okay? We want to use this for a scale. We want to change our map. So what will the dimensions of Kansas be on our map? So the first thing we need to do is find the actual dimensions of Kansas. So if 1 centimeter is 100 miles, we can easily figure out, setting up a proportion, and a lot of you probably already said, well, this is how you just multiply 100 times 2.1 and you get 210 miles. So we multiply 4 by 100 and we're going to get 400 miles. Okay. Now we need to convert the other way. We want 2 centimeters to represent 125 miles. So how much would 210 miles be in centimeters? Now we've changed it a little bit. When I cross multiply, I get 125x equals 420. And I divide both sides by 125. I get x equals 3.36 centimeters. Okay. On the next one, they're asking for the dimensions of Kansas again. So we are using 2 centimeters. Represents 125 miles. So how much will 400 miles be? When I do the math on that and I cross multiply, so I have my two sides. So my dimensions then are 3.36 centimeters times 6.4 centimeters. Okay? All right. A couple more slides. You're planning a neighborhood. The rectangle shown is a scale drawing of the roof of a rectangular building. You used a scale of 2 inches to 75 feet. What would be the dimensions of the drawing, of the roof in your drawing, if you used a new scale of 100 inches equals 100 feet instead? I'm going to let you try this, and then we're going to come back. On this, when I did my work, I set up my two proportions. I got the first side to be 2.25 inches, and the second side to be 3 inches. But where did I get this 225 and this 300 from? Well, I knew 2 inches represented 75 feet. So if I multiply 2 by 3, I get 6, so 75 times 3 gives me 225 feet. And 2 inches represents 75 feet, so multiply by this by 4, and then multiply this by 4. So when I do that, I get 300 feet. That's where these two numbers here came. Okay? What I want you to do is I want you to think about this here. Consider two scale drawings of the same object. The drawings have scales of 1 to 2 and 1 to 3. I want you to tell me which drawing is larger, and I want you to explain, and we will discuss this in class tomorrow. Have a great night.